Hello, we are Team 29, and our project was classifying artworks by their specific artists using a convolutional neural network. Our motivation was that our group is very interested in art, and being able to classify paintings is a big challenge whenever new, unseen paintings from famous artists appear. I am Melvin Ricci Slakana.
And I'm Radek Bedoko. And so the data set we originally started out with was from the best artworks of all time for Kaggle, which was about 8,000 artworks from 50 different artists. Now, training this became immediately clear that this is going to be very difficult due to this number of images and these image sizes. And so we had to first reduce down this data set to 200 artworks from the top 10 artists in order to figure out how we would actually improve upon this model before building it back up to the full data set. And just for reference, this takes us about a minute 30 seconds to train on Colab and about 30 seconds locally with a RTX 3070 on that 2000 artwork data set.
One of the challenges presented with this dataset was the imbalance of artists to their paintings. By using data augmentation, we trained our model to be more robust by using different perspectives to view the painting. These perspectives correspond to how an individual may view artworks differently, such as zooming in with a camera or slightly tilting their head. The techniques we used included zooming into certain parts of the painting, rotating the painting, and flipping the paintings horizontally and vertically. We found that flipping the paintings over the axis worked the best for augmentation. As you can see with the rotations, it ended up messing with the edges around the data, which was very detrimental to our model.
And so we basically went to experiment with two different types of models, both of which use the ResNet 50 as sort of like a transfer model. And so the difference between these two GAP and SPP model is the pooling layer. So for GAP, we use an average pooling layer versus an SPP, we use a spatial pyramid pooling layer, which we had read about and saw that it would allow us to use images from multiple sizes, which we thought might allow us to try interesting strategies. And so we built the baseline, and our score is about 85.5% F1 for the GAP and 84.4 for the SPP. And then we tried to improve these models by adding these dense blocks, which consist of dense, dropout, and batch normalization. We created this search space here for block 1 and for block 2, and we tried out all these combinations and ranked these by the F1 score. And pretty much what we see is that the GAPS model were able to outperform the SPP models, and we ended up with a final score of 87.7%. And now we have plotted the loss and the F1 score for the baseline model. And so what we can see is in the red lines, vertical lines, these are whenever we reduce the learning rate on a plateau of about 4 epochs. This reduction is about a factor of 10, and we can see there's about 3 of them before we actually reach our best epoch colored in black. For the actual improved model, we start off by loading in the weights from the baseline model. And so that is why we have this slightly higher starting F1 score or validation F1 score. And from here, we see that there's only 1 reduction of learning rate required before we end up reaching our best epoch. And then finally, we do an evaluation, and here is our confusion plot. And so there's not much difference between the baseline model and the F1 and the improved model, because there's only about a 2 or 3% increase in the actual score. And so it's very difficult to see any much difference when you look at this more closely. But one thing we did notice is that the majority of the confusion was for this artist, Edgar Degas, and he was confused most often with Pablo Picasso and Pierre-Augustin Renoir. And this is because these are very actually similar artists. These are from the similar time frame, and these are all impressionists.
Once we were satisfied with our model, we trained the model on the full data set with all 50 artists included. We incorporated transfer learning by initially freezing the baseline ResNet 50 model and only training over the last few dense and batch normalization layers. For the validation set, our F1 score was 82.4%. Lastly, we unfroze our baseline model and fine-tuned it with a very low learning rate with a few rounds of training. This helped increase our final validation F1 score by about 1%. In conclusion, we were able to take a small subset of 10 artists with 200 artworks from our overall dataset, and from that, we were able to experiment and improve our model. From that, taking our best model from that series of sets, we applied the model to the full dataset, which allowed us to train a baseline and improved model. This improved model is incredibly close to our results with only 10 artists, which is very impressive considering how much more difficult this full dataset is. Overall, we are very satisfied with how this project unfolded throughout the semester, and we're very happy to be a part of it. Thank you.
Thank you.